Math 3, Unit 8, Section 6. Today we're going to begin talking, or actually continue our talk on radians. So we started talking about radians last time in class. If we were going to write this table here, okay, we know that 360 degrees is the same as 2 pi, right? Do you guys remember that? Yes? Okay, and we know that 180 is how much? 1 pi, or just pi. Good. Very good. 90 is half of 180, right? Which is pi over 2. Do you remember what 60 degrees was? Yeah. So sometimes when you're going through here, it is difficult to like figure out what it is just off the top of your head. But there is a way that you can always find it out. And basically by knowing that 180 degrees equals pi, you can end up reducing and changing anything from degrees to radians or anything from radians to degrees. So if I were to take 60 degrees here and we want to change it to radians, you would multiply 60 times pi over 180. Okay? Can 60 and 180 reduce? Yeah, 60 and 180 reduces to be what? 3. And so 60 is actually pi over 3 radians. Okay, 45, same thing. 45 times pi over 180. 45 goes into 180. How many times? 4 times. So this is pi over 4. And then 30 times pi over 180. This reduces and it's pi over 6. So we can do this with any degree and change it, okay? We can also go the opposite direction, okay? And so if you have pi and you're wanting to change it or convert it to degrees, okay? So we can either convert to degrees or we can convert to radians. If you're wanting to eliminate the pi and get into degrees, you would just multiply by 180 over pi. So I'm going to write this out, 11 pi over 12 times 180 over pi. So when you have pi in the denominator like this, you can notice right here that the pi's reduce. Okay, and then 12, if you divide 180 by 12, you can reduce those, and 12 goes into 180. 15 times, and we're left with 11 times 15, which is 165 degrees. Okay, so on this one, can you change that for me or convert it? I'm going to give you guys a minute. So we're changing 330 degrees to radians.
How do you get 165 again?
So we started with 11 pi over 12. We reduced the pi's. 12 went into 180 15 times, and all I did was multiply 11 times 15. All right, so did you guys get an answer? Always. Yep. So 330 degrees times pi over 180. So when I want to put it into radians, the pi is on the top. When you're wanting to eliminate pi, pi goes to the bottom. So it will always be 180 and pi. So just depending on which way you're going is how you would write that fraction. Okay, and so here, also remember that anytime you have a 0 on the top and the bottom, that's like having a times 10 on the top and a times 10 on the bottom, so I can cancel out the zeros. And then 18 and 30, can we divide by a number and reduce those? 3. And so 3 goes into 33 11 times, and 3 goes into 18 6 times. And so on the top here, when we're multiplying across, you're left with 11 pi. And the denominator, we have 1 times 6 left, which is 6. And so that 330 degrees is the same thing as 11 pi over 6. Okay. So we're going to go ahead and within our unit circle, we can convert every single degree and the unit circle to radians. Okay? So if you take your unit circle out here, okay, starting at 0, it is 0 radians. Do we all agree with that? Okay, so we're going to put a 0 right here. Okay, we already figured out 30 degrees in our notes, and 30 degrees is equal to what? Pi over 6. And specifically, it is really 1 pi over 6. So I'm going to show you guys a way of writing this relatively quickly. If you go, we're going to skip 45 because you know how the 30s are different than the 45. So we're going to skip 45 here for a minute. 60 degrees was what? If you go back to the sheet, what do we find out? Pi over 3. Okay, now this really pi over 3 is the same thing as 2 pi over 6. Does 2 pi over 6 reduce to be pi over 3? Yes. And so for 60, I'm going to write this as 2 pi over 6. Okay, 90 degrees we have as pi over 2 that we already found out. But I want you to also recognize that pi over 2 is the same thing as 3 pi over 6. Because 3 pi over 6, what does that end up reducing to be? Pi over 2. Pi over 2. Okay, 3 pi over 6. Do you guys notice any pattern right now with how these radians are written? Yeah, they're going up by 1 and they're all over 6. Do you guys see that? So when we get to 120 degrees, what do you think that's going to be? 4 pi over 6 is correct. We skip the 45. What will be the next one? Good. 5 pi over 6. And then when we get to 180, that is going to be 6 pi over 6, which makes sense because it reduces to just be what? Pi. Okay? 210, what will that be, do you think? You're right, 7 pi over 6. We skip our 45 degrees. This one's going to be 8 pi over 6. At 270, it's going to be 9 pi over 6. At 300, it's going to be 10 pi over 6. We skip our 45 degree. At 330, it's going to be 11 pi over 6. And then at 360, it is?
2 pi.
Good. And I'm going to write this first as 12 pi over 6. But we know that ends up reducing to be 2 pi. Now, it's better to go back and reduce any of these that you can. And so, for instance, here, 2 pi over 6 reduces to be what?
Pi over 3.
Pi over 3. Okay? But you could leave it either way. But this would be pi over 3. 3 pi over 6 would actually reduce to be what? Pi over 2. 4 pi over 6, could that reduce? We can divide by 2, right? And so we'd end up with 2 pi over 3. 5 pi over 6 can't reduce. We already reduced the 6 pi over 6. 7 pi over 6 can't reduce. 8 pi over 6, that would reduce to be 4 pi over 3. 9 pi over 6, 3 pi over 2. 10 pi over 6, 5 pi over 3, and then that looks like we've reduced all of them. Okay, now going to the 45 degree. 45 was what? Pi over 4. Okay, so this is pi over 4. And specifically even, we can write that as, that's 1 pi over 4. When you get to 90, it would end up being 2 pi over 4, which would reduce to still be pi over 2. Does that make sense? So I'm going to write it here, though. So this is the same as 2 pi over 4, which we know ends up reducing to be pi over 2. Guess what the next 45 degree is going to be? 3 pi over 4. Very good. And then when you add one more, we get to the 180, which would be 4 pi over 4, which is just pi. What's going to be 225? 5 pi over 4. When we get to 270, this will be 6 pi over 4. And again, if you look at this, this will end up reducing to be 3 pi over 2. So this is 6 pi over 4, and guess what this one is? 7 pi over 4. And when you get back here, you'll end up with 8 pi over 4, which reduces to be 2 pi. If you ever forget what one of these is, though, you can just convert it by multiplying by your pi over 180, and you can get it. So if you use pi over 180 to just get 30 and 45, you know the pattern is by adding by 1 all the way around and then reducing. Do you guys have any questions right now? Can I what? This one? Okay, so we're going to go back over here. I do all that because I feel like it's pretty helpful for dealing with these problems. On each one, they ask us to sketch our reference angle, okay, for each of the quadrants, and then we need to find cosine, sine, and tangent. Okay. Pi over 6, where will that reference angle end up in? Which quadrant? Quadrant 1, very good. So we draw this, we end up in quadrant 1. We're going to label this as pi over 6. Now, because we just did all of that work on the unit circle, can you guys find where pi over 6 is on your unit circle? Do you see that it's right here? Pi over 6. Okay, and so based on that information, okay, we know that the ordered pair at pi over 6 is root 3 over 2, 1/2. Okay, we also know that sine represents the y. So therefore, the sine of pi over 6 is what? 1 over 2. Cosine would be what? The x, which is root 3 over 2. And tangent, we know, is y over x, and we know our denominators end up reducing. And so what would I write for tangent? 1 over root 3, and then you would need to, can we have a root in the denominator? No, so rationalize the denominator, and we end up with root 3 over 3. Anyone have questions? Okay. 3 pi over 4. Where is that going to end up? Quadrant 2. Does everybody agree? So we'll go ahead and draw our reference angle. We end up here in quadrant 2. We write this as 3 pi over 4. Can you tell me the ordered pair at 3 pi over 4? What is that? Very good. So we have negative root 2 over 2 and positive root 2 over 2. It's our x and our y. Okay? So what is sine? Root 2 over 2, because sine is our y value. Cosine is our x value, and so that would be what? Very good. Negative root 2 over 2. And we know that tangent is y over x. We know that the denominators will end up reducing, and so we end up with root 2 over negative root 2. And what does that reduce to be? Negative 1. Okay, go ahead and do that third example on your own. Do I volunteer? Does anybody want to come up and do it? Okay, you're good now? So this one right here reduces to be that. Okay, do I have a volunteer of somebody that wanted to come up? Is that you, Trini?
Yeah.
The only thing is that on this one and negative, and then this should go in place, which then has the product.
Do you want to do it? Yeah. Okay, yeah. All right. I'm going to make this just a little bit. Oops, wrong way. Okay, here we go. So first of all, 4 pi over 3 ends up in quadrant 3. And so Trini's drawing her reference angle, and it ends up with 4 pi over 3 in that quadrant. Okay, the ordered pair, based on our unit circle that we already did all that work for, ends up with negative 1/2 and negative root 3 over 2. We know sine is y, which makes that negative root 3 over 2. Cosine is x, which makes it negative 1/2. And then when you're doing your y over x, you end up with negative root 3 over negative 1, and that reduces to be a positive root 3. Okay, do we have any questions on that? Perfect, thank you. I'll give you your point later. And then that was, okay. All right, let's go ahead and turn the page. Are we good? We're just gonna do 1 here when it's a negative. Okay, so if you're looking at your unit circle, and we know that pi over 3 ends up here, if it's negative, we're just going to go that same direction, negative. Does that make sense? So on here, it's saying negative pi over 3. So if this is positive pi over 3, where is negative pi over 3 going to end up? It will end up in quadrant 4, and then it's going to end up right here. Do you guys agree?
Yeah.
For some of you, you could even like count like it's 1, 2, 3 away makes pi over 3. So starting at 0, we're going to go 1, 2, 3 away, going the negative or the opposite direction. Okay. So negative pi over 3, we're going to go clockwise for negative. We end up at negative pi over 3 there in quadrant 4. And that ordered pair, what was that? Very good. 1/2 negative root 3 over 2. Okay, and so we know this is our x and our y. We know sine is y, cosine's x, tangent is y over x. So sine ends up being what? Negative root 3 over 2. Cosine is positive 1/2. And then tangent with y over x would be negative root 3 over 1, which is just negative root 3. Okay, any questions? All right, so on this next part, they asked us to sketch the angle again, find sine, cosine, tangent. Where is pi? Where does pi end up? Very good, at the 180. So remember that this is called a, very good, quadrantal. What is the ordered pair there at 180? Very good, negative 1, 0. And so again, we have our x and y. We have y for sine, x for cosine, and tangent is y over x. So therefore, what is sine? 0. What is cosine? Negative 1. And when we go 0 over negative 1, what does that equal? 0. Okay, so remember that if you ended up with the 0 in the denominator, it's undefined. Anytime it's under, it's undefined. Okay, 6 pi. Remember that each 180 is pi, or each whole circle is 2 pi, correct? And so if you're drawing this, you could even count like this is 1, 2, 3, 4, 5, 6, and we end up right there. Or you can count by 2s, right, in doing the whole circle. Okay. What is the ordered pair when you end up there?
1, 0.
Very good. 1, 0. We have our x and our y value. So going through here, sine we know is y, cosine is x, tangent is y over x. What is the sine value?
0.
What is cosine? And what is tangent? 0 over 1, which is 0. Okay, do we have any questions? All right, and then last one, pi over 2. I'm just going to give you about less than a minute to do all that on your own. Okay, so where do you end up? Very good, at the 90-degree mark when you're drawing that. And what ordered pair there is it at 90? Very good, 0, 1. And so what is my sine value then? Very good, cosine is 0 and tangent is 1 over 0, which is no solution or undefined. Okay. Review, it says find the ordered pair on the unit circle for each angle. So 11 pi over 6, what is that ordered pair? Very good. Relatively easy based on having the unit circle. Okay. Do you guys remember how to find the ordered pair that's missing on this one? Okay. The last time in notes when we recorded it, I forgot the negative. But this one's going left and up, correct? And so we have the y value, and the y value is positive. But because this is going left, we know the x value will end up being negative. Okay? Since this is 1, we want to change it to have a common denominator. So we change the 1 to be what?
17.
Very good. 17 over 17. What value am I missing? My x, which we're going to give a denominator of 17. And how do I find that numerator? Yeah, good. Pythagorean theorem using 8 squared plus b squared equals 17 squared, or you could have done a or x or whatever variable. 8 squared is what? 64 plus b squared equals, and 17 squared is? Very good. And then we subtract 64, and we have b squared equals, which means that b is equal to what? 15. And so now we have our ordered pair, which is negative 15 over 17 and 8 over 17. Any questions?